All right, so today we're talking about a visitor from deep space, one that is absolutely breaking all the rules we have. It's a comet called 3I/Atlas, and honestly, it's giving scientists a cosmic puzzle that challenges pretty much everything we thought we knew about these things. You know that classic image of a comet, right? It's got a bright, glowing head and this long, beautiful tail that's always pointing away from the sun. But what if I told you that this comet has a giant tail that seems to completely ignore that rule, and instead it points toward the sun? Yeah, that's the bizarre mystery we're diving into. And we're not talking about some little quirk here. The scale is just mind-blowing. This structure, which we call an antitail, stretches out for over 384,400 kilometers. To put that into perspective for you, that is farther than the distance from the Earth all the way to the moon. Something really, really strange is going on here. So, this is the core of the problem. We have a comet with this enormous physical structure that's pointing straight into the solar wind, defying the very forces that are supposed to be pushing it away. So, let's break down the clues like a proper cosmic detective case. Okay, so clue number one is that unbelievable size. I mean, a feature this huge, pointed directly at the sun, should not be possible. It's kind of like seeing a flag flying straight into a Category 5 hurricane. It just doesn't make sense. So how do we even start to explain it? Well, first, let's make sure we're all on the same page with our terms. See, usually, when astronomers talk about an antitail, what they're really talking about is just an optical illusion. It's a trick of perspective. It happens when Earth moves through the comet's orbital plane, and it makes some of the heavier dust particles look like they're pointing toward the sun for a little while. It's a geometric thing, and it's temporary. But with 3I/Atlas, it's a completely different story. With a normal comet, the sun's energy blasts dust and gas away from it. Simple. But here, we are seeing a massive, physical structure that's just hanging out, day after day, pointed right back at the sun. This is no illusion. This is real. And here's the kicker. The sun's radiation and the solar wind should have just shredded this thing, blowing it all away almost instantly. The very fact that this moon-sized tail exists and stays put tells us that our standard understanding of comets, well, it's missing a huge piece of the puzzle. All right, on to our second clue, which just adds another wild layer to this whole thing. It wasn't just that the tail was there, it's that astronomers noticed it was unstable. It was wobbling. But what's really fascinating is when this happened. The wobble was spotted before the comet reached perihelion. That's its closest, hottest, most intense point in its orbit around the sun. And that is the complete opposite of what you'd expect. So that just begs the question, right? If the sun's heat is what really drives a comet's activity, making it spew out gas and dust, why would its tail get all wobbly before the heat was even turned up to max? It strongly suggests the cause isn't just the sun. It's got to be something internal, something happening inside the comet itself. Okay, so we've got our clues, an impossibly huge antitail and a very mysteriously timed wobble. So let's put on our detective hats and look at the prime suspects, the leading scientific theories that might just crack this cosmic case. Scientists are really zeroing in on a few main possibilities. One, maybe the comet's core, its nucleus, is spinning in some really complex, wonky way. Two, maybe there are powerful jets of gas shooting out, basically acting like little rocket thrusters and pushing the comet around. And a third idea is that maybe the dust itself is just plain weird. So let's look at those first two ideas for the wobble. A complex rotation means if the comet's nucleus is shaped like a lumpy potato and it's spinning, different parts of it get heated up, releasing gas from different spots and making the tail's origin point shift around. Or you've got the gassy jets theory, where these uneven jets literally act like engines, pushing the comet off its path and causing that big tail to wobble in response. And we can't forget that massive tail. To stand up to the sun like that, the comet has to be constantly feeding it new material. This means a ton of gas must be escaping its surface. Or maybe the dust particles themselves are just way tougher than usual. Maybe they're denser or stickier, making it a lot harder for the sun to just blow them away. And now we get to the final, crucial piece of the puzzle. The one thing that might just tie this all together. Why is this comet so incredibly strange? Well, the answer lies in where it came from. This is the key. You have to understand.
3I/Atlas is an interstellar visitor. It wasn't born here. It formed in a totally different solar system, orbiting a completely different star. It's been wandering through the darkness of deep space for who knows how long, and now it's just passing through ours. It's an alien, and it's playing by a totally different set of rules.
Think about it. Everything about this thing, its chemical makeup, the way it's put together, the kinds of ice and dust it's made of, all of that was decided in an environment we have never seen. So its bizarre behavior isn't a flaw, it's a feature. Its normal is just not our normal. That super tough, sticky dust we were talking about, maybe that's just standard stuff where this comet comes from.
And you know, this really gets at something beautiful about the process of science. The fact that this comet just refuses to fit into our neat little boxes isn't a problem. It's an incredible opportunity. Paying close attention to these weird things, the stuff that looks wrong, is exactly how we push forward and learn something new about the universe. And that's why this is so incredibly important right now. 3I/Atlas is giving us this fleeting, rare chance to study the building blocks of another solar system right here in our own backyard. As it flies away, back into deep space, it's going to fade, and this chance will be gone forever. The data we're getting right now is absolutely invaluable. It's like a message in a bottle sent from a distant star. So as we watch this cosmic rule breaker head back into the void, it leaves us with this incredible, tantalizing question. This is only the third interstellar object we have ever confirmed. So what other secrets, what other amazing surprises are drifting through the darkness, just waiting to pay us a visit?